Biofuel is any fuel that is derived from biomass, such as wood, alcohol fuel, crops, garbage, landfill gas. It offers plant-based solution to the Earth's growing energy problems. With the recent rise in oil prices, along with growing concern about global warming caused by carbon dioxide emissions, biofuels have been regaining popularity. There is various ways of making biofuels. They generally use chemical reaction, fermentation, and heat to break down the starches, sugars, and other molecules in plants. The leftover products then refined to produce a fuel. On the back of this, biofuels look like a great solution. Cars are a major source of atmospheric carbon dioxide, the main greenhouse gas that causes global warming. As plants absorb CO2 as they grow, crops grown for biofuels suck up about as much CO2 as comes out of the cars that burns these fuels. Biofuels are renewable resources as we can always grow more crops to turn into fuel. Common types of biofuels are ethanol, biodiesel, and biobutanol.
Ethanol is produced from a biomass mostly through a fermentation process using glucose derived from sugars, starch, or cellulose as raw materials. In this form, it is renewable, while synthetic ethanol can also be produced from non-renewable sources like coal and gas. The first generation of bioethanol or conventional ethanol is manufactured via a process where glucose is transformed by yeast into ethanol and carbon dioxide called fermentation. Starch, however, requires pre-processing where the starch is transformed into glucose through a process called liquefaction and saccharification. Firstly, there is a liquefaction process. By using bacterial alpha amylase that produced from the Bacillus subtilis into the starch, we will obtain maltodextrin along with the maltose and maltotriose. Secondly, there is a process called saccharification. In this process, the maltose and maltotriose will be hydrolyzed into glucose by aminoglucosidase. Theoretically, starch can be hydrolyzed completely to glucose by enzyme called aminoglucosidase or glucoamylase. But in practice, a little maltose and isomaltose is produced too. This process through the addition of enzyme that will freeze the glucose bound in the starch and make it available for fermenting into alcohol. In contrast to first generation bioethanol, which is derived from sugar or starch produced by food crops, cellulosic ethanol may be produced from agricultural residues, other lignocellulosic raw materials, or energy crop. Cellulosic ethanol, a second generation bioethanol, is chemically identical to first generation bioethanol. However, it is produced from different raw materials through a more complex process called cellulose hydrolysis. As the main component of lignocelluloses, cellulose is a bipolymer consisting of many glucose units connected through a beta-1,4-glycosidic bonds. Breakage of the beta-1,4-glycosidic bonds by acid leads to the hydrolysis of cellulose polymers, resulting in the sugar molecule of glucose or oligosaccharides. Mineral acids such as hydrochloric acids and sulfuric acid have been used in the hydrolysis of cellulose. However, they suffer from problems of product separation and poor catalyst recyclability. The use of heterogeneous solid acids can solve these problems through the ease of product separation and good catalyst recyclability, such as sulfonated carbonaceous base acids, polymer base acids, and magnetic solid acids. The key factors for effective hydrolysis processes are the acid strength, acid site density, absorption of the substance, and micropores of the solid materials. Through cellulose hydrolysis, by adding acid or hydrolyzed enzyme will resulting in sugar molecule glucose that will make it available for fermenting into alcohol.
Biodiesel is an alternative fuel generated from biomass consisting of long-chain alkyl ester. It's typically made by chemically reacting lipids with an alcohol-producing fatty acid esters. Biodiesel is renewable and clean-burning. The very first step in the biodiesel process is the extraction of oil. It is known as a trans-esterification. Trans-esterification is essential as plant and animal oils are highly viscous as compared to the fossil traditional diesels. It is a reaction of a triglycerides with an alcohol to form esters and glycerol. Fats and oils are chemically known as triglycerides. It has glycerin molecules as its base with 3 fatty acids attached. Fatty acids are a long chain of hydrocarbons with carboxylic acid. Under normal conditions, the reaction will proceed exceedingly, maybe not at all. Heat and catalysts are used to speed up the reaction. Common catalysts for trans-esterification include sodium hydroxide, potassium hydroxide, and sodium methoxide. Biodiesel process using base catalysts are the most economical process, requiring low temperature, pressure, and producing higher yield. The presence of water causes undesirable base hydrolysis, thus the reaction must be kept dry. The reaction then undergoes separation and purification as it produces biodiesel and impure products at the same time. The byproducts such as salt, glycerol, excess alcohol, and trace amount of water should be removed to meet the standards.
Butanol can be produced by chemical synthesis. One process is oxosynthesis, which involves the reaction of propylene with carbon monoxide and hydrogen in the presence of cobalt or rhodium as a catalyst. The mixture of N-butyraldehyde and isobutyraldehyde are obtained, and then the mixture can be hydrogenated to the corresponding N-butanol and isobutyl alcohols. Hydrogenation processes by using the catalyst of nickel or copper in gaseous phase or nickel in liquid phase. Some byproducts can be transferred into butanol at high temperature and high pressure that will enhance the product purity. Another route is aldol condensation, which involves the reaction of condensation and dehydration from 2 molecules of acetic aldehyde. And then the product crotonaldehyde was transformed into N-butanol by hydrogenation at 180 Celsius and 0.2 MPa. Comparing the two processes, oxosynthesis route has the advantages of materials easily obtained, comparable moderate reaction conditions, enhanced ratio of N-butanol to isobutyl alcohol. So, oxosynthesis process is the main industrial route for N-butanol production. There are also some other fossil oil-derived raw materials such as ethylene, propylene, and triethylammonium or carbon monoxide and hydrogen are used in butanol production. In conclusion, biofuel is an alternative source to burn fossil fuel derived from biomass which is renewable, biodegradable, and environmentally friendly. As oil spillage is not a big deal anymore, microbes can easily break them down. Lower carbon emission and the use of carbs to produce the biofuels help to absorb carbon dioxide coming from greenhouse gases and burning, which can be positively affected to the global warming problems. Even though biofuels has lower density than fossil fuel, where it requires more fuels to provide the same amount of energy, but through research, we are looking forward that the biofuels become the best alternatives resource, which can completely change the usage of fossil fuels into biofuels for a greener and better world.